I'll just give it a second for everyone to join the stream. And we can go ahead and get started. Okay. Hello, hello, everyone. How are we all doing today? I'm just setting up my other browser, so in case chat randomly dies as it's done, not a while ago, but I have that ready as well. In case chat does die, I'll be able to still see you guys type in. What is up, Luke? What is going on, my man? And I finally have some water as well. My mouth gets so dry sometimes, but I always forget to bring like a glass of water. All right, so I'll give it like a minute or two. And then we can go ahead and get started with lesson 13. Blue hand coding is greater than AP computer science principles. Yes. Also because AP computer science principles is, if I remember, it's not even real coding. Okay, well, block coding is coding, I guess, but it's still not like typing stuff out. Funny story, actually. I never took AP CSP, but I know for the class you have to do like a final project. And 2 or 3 years ago, a friend of mine reached out to me, and I ended up just doing the whole project for him. I probably shouldn't admit that now, but yeah, that was a fun time. So cool. I think we're all ready to go ahead and get started. Hello, Maria. Yeah, so let's go ahead and get started. New haircut? Yes, new haircut indeed. It was getting too much. I gotta keep it professional, especially for streams. Um, Honestly, not really a fan of the short sides, but it's okay. Clipped and sent to College Board. Yeah, I wish. College Board is. Ugh. Anywho, here we are, lesson 13. It's August 20th. I don't know why I mentioned that. Yeah, lesson 13. We're going to go from 12 p.m. Eastern Standard Time to 1:30 p.m. Eastern Standard Time. So an hour and 30 minutes for this lesson. If we go overboard, it's fine. So yeah, let's go ahead and first let's start off with a review. I know I did a review last time, but it was more of just like a finishing up the project. So now let's do a proper review of what we did in lesson 12. So with lesson 12, we really focused on this whole Pokemon game. So we wanted to use what we learned in lessons 11 with object-oriented programming and see how we can use that to organize our code in a newer, more efficient way, make our code more readable, represent these complex objects in code. So again, we made this Pokemon game. It was a one-player game, us versus a bot. We made use of 2 different classes, right? So we have our Pokemon class, and then we have an attack class. So again, let's start off here from the top. Let's work our way down. So we imported a random. Why? Because we want to randomize the amount of damage that our Pokemon does. So that's what we're using our random library for. Now let's come down here to our attack class. Now, again, we use classes to represent these complex, multifaceted ideas, okay? So how would you represent an attack? An attack has its name, right? An attack has the amount of energy it uses, from the person using the attack. And an attack has the amount of damage that it does. So when we instantiate an instance of our attack class, we need to give it those features, right? A name and the amount of energy used. And as I mentioned earlier, we're going to just generate a random number between 9 and 15 that'll be the amount of damage it does. So that's just what this is doing. Again, this is our init dunder method. So whenever we create an instance of our class, remember we just put whatever is equal to attack, and in those parentheses, we're instantiating our class. We're creating that class. So what this init dunder method is telling us is that we have to give in a name and the amount of energy used. So that's our attack class. Finally, we're also using this str dunder method so that when we just use our print function, instead of printing out this whole, x dot, class attack at x dot 077, whatever, right? It doesn't format so nicely. It'll just print out the name of the attack. So it'll look a lot nicer for our user when it gets printed out to this console here. Now we get to the sort of meat of the code, our Pokemon class. And I call this the meat of our code because all of these methods, they're really just doing all the work for us. And again, we're also using our attack class within our Pokemon class. So again, let's think how we would represent a Pokemon. A Pokemon has a name. It has a special type. It has the amount of health it has, the amount of energy, the amount of energy reserves it has, and the amount of attacks that it has. So these are some things that we want to set as soon as the instance is created. And again, the only features that I'm allowing the user to have a say in is the name of the Pokemon and the type of the Pokemon. Now, I'll start with this dunder method first because we're all pretty familiar with it, right? It's really useful. So when we print out a Pokemon, we want to print out its name. We want to say, hey, this Pokemon has XYZ health points left. That's XYZ energy points left. So we, as the player, as the user, we get a pretty quick, brief rundown of the status of our Pokemon. All right. And finally, we have our set attack function. So what this will do is it'll allow our user to give a name for an attack and the amount of energy that this attack will use. And it'll create an instance of this attack class and save it to the attacks list. And finally, when we're attacking an opponent, right, our Pokemon wants to attack an opponent, our Pokemon needs to know what attack to use, and as well as who the opponent is. And given that, we want to check to see if we have enough energy, right? If our Pokemon has enough energy to even make the attack happen. And if it does, we're going to take away the energy level that we're using, right, from our attack. And from our opponent's health, we're going to take away the amount of damage that our attack is doing. And again, that's what this if statement is doing here. So if our Pokemon doesn't have enough energy levels to make whatever attack happen, we're just going to print out, hey, whatever doesn't have enough energy points, you'll have to wait another turn. So this right here, lines 10 to 44, really the meat of the whole thing. Everything else is pretty straightforward. Oops. Everything from 45 onward is just basic game setup stuff that we've done before several times over. We have our wild true, we have our breaks. So nothing too complicated. I really don't want to spend too much time going over any of this stuff because it's really the easy stuff. But if you guys would like me to go over it, just let me know right now. Because honestly, I'm really excited for today's lesson. I feel like we have some really cool things. At least I have some really cool things that I want to show you guys. Okay. So I just realized, is the quality of the stream okay for you guys? Because again, you got to realize I have two browsers open so I can see what the stream might look like on your end, and it's looking a little blurry. Just let me know. Is it readable and everything like that? Because if it's not, it's blurry now. Okay. Here's what we'll do. Maybe a little blurry, but def readable. Okay. I don't want to, switch my Wi-Fi right now because it might cut the thing. But if it gets really bad, then I'll stop the stream for a sec, change the network, and come back. But I think we're okay for now. All right. Okay, perfect. So yeah, we're all good with this. I'm not seeing any questions. So now I want to give you guys a rundown of what we're going to be doing next. Let me come over here to our lesson 13 REPL. So I'll tell you what's in store for this lesson. We're going to talk about inheritance. Inheritance is an OOP principle that's really useful. After that, in our last review, I asked Luke if we wanted to do a blackjack game or if we wanted to make an ATM as our sort of culmination of our beginner OOP introduction. So we're going to be making a blackjack game, and then we're going to be switching on to something called tkinter. Tkinter. And what tkinter is, it's a library that allows you to create applications. And I don't mean something that, will pop up in the console. I mean full-fledged, if it's on your desktop, you click it, a little screen pops up. It's got buttons you can click. We'll do GUI development with that. GUI with that. But again, we might not have time for that today because I do want to close out our OOP lesson. But I just want to get you guys excited for something. So, inheritance. This is one of the 4 pillars of OOP. And again, you're thinking, okay, well, this is one of the pillars. We talked about the other pillars. Not really. The other pillars are sort of more useful later on. Inheritance is the one I use really frequently, and I feel like a lot of people use it as well. There's other ones like polymorphism and whatnot, but again, inheritance is the best one. That's just weird. But what inheritance is let's say I have 2 classes, right? And I'll explain it first, and then we'll go into the code. Let's say I have 2 classes, sort of like an animal class and a dog class, right? Now, let's think about an animal. An animal has the ability to eat, the ability to sleep, right? The ability to make noise. A dog can do those same things. It can eat, it can sleep, it can make noise. But let's say we have code, right? Let's say we have those 2 classes. We don't want to repeat ourselves. So what we can use is we can use inheritance to sort of reuse a class. Okay? So let me show you guys an example. Again, let me go back to my example of animal. So if I have class, we'll call it animal, right? And when I create this animal, I won't give it anything. I'll just put self, so that means we don't have to create anything. We'll just say that this animal, actually, let's give it a name. Okay. And we'll say that self.name is equal to name. So this animal has a name, okay? And we'll create a method that prints out that name. So we'll just say print name self. I'll just print f string my name is self.name. All right. So now let's go ahead and create an instance of this class. I'll just call it X for whatever reason. Animal, and again, we have to give it a name, so we'll call it Luke. Just the first name that came to my mind. So again, we run this, no errors. And to see that it's working, we can just, use this print name method that we have. Print name. I run this, we say this, my name is Luke. Perfect. Now, let's say that we have something like another class, right? We have a class called, one second. Yeah, so we have a class called dog, okay, or cat, doesn't really matter. Now, with this dog, right, we also want it to have, the ability to have a name and whatnot. And so what we're going to do is we're going to have this dog class inherit from this animal class, if that makes sense. So again, let me show you how the 2 of these can be the same thing. Self name name equals name f print name self print f string my name is self oops it's a lowercase self.name. Yeah, so these both do the exact same thing, but again, let's just say we wanted to have that dog class to do something else, or we could just say, Let's add um, woof, right? So this dog is just going to say woof, woof. All right. Again, let's look at these two classes. What do I notice? Well, I notice that these two methods are the same exact thing, right? This init dunder method does the same thing. It sets a self dot name, and the print name method does the same exact thing. It just prints um, self dot name. So again, let's come down here and I'll show you that they're doing the same exact thing. I'll just create this called R. Oops, I'll say R is now equal to a dog. Call this one Varun. Do R dot print name. Dot print name. So this one says my name is Luke. My name is Varun. But now this dog class has given me the extra functionality to say r.woof, which if I run, will say woof, woof. So one of the main things with Python, or not in Python, but just coding in general, is we don't want to repeat ourselves, right? We want our code to be tight, efficient, and get the job done. So what I'm going to show you is how this dog class can sort of borrow the abilities of this animal class. Okay, I'm going to come up here to where I'm saying class dog, and in parentheses, I'm going to put animal. Okay, I've just done that. And if I run these, they do the same thing. So we need to manipulate this a little bit. And actually, let's start by getting rid of something like the print name function method. Let's see what that does. Still working. What happens if I get rid of this init function? What's going on here? Still working. So what's going on here? Let me rewind it a little bit. You guys can kind of see how this is really like overpowered. I'm basically just removing these lines of code because I can just reuse them from this animal class. So again, let's reiterate. I sort of picked up my pace there. I was going kind of slow. We have our animal class. This animal class is an init dunder method, right? Where you give it a name and it sets that as an attribute. It also has a print name method, which will just print out that name attribute. Now, this dog class has two methods that do the exact same thing, right? They both work the same way. So what if we can reuse the code from this animal class with this dog class? And that's what inheritance will be used for. So to inherit, we just put those parentheses and we put the class that we're inheriting from. And now that I've inherited from the animal class, you can sort of think visually that these lines of codes that I've highlighted here are now a part of this dog class. So I can actually go ahead and remove them. When I do that, we said my name is Luke, so we know our animal class is working. Nothing's changed there. And with my dog class, it still works just fine, right? And it does woof woof and everything like that. So how do we feel about what I've shown you guys right here? Thoughts on this? Does it make sense? You guys okay with it? Let me know. You can inherit from multiple classes, yes. But again, that's inheriting from multiple classes it can happen. But I'm trying to think of like the best way to word this. It might get a little bit messy, if that makes sense. I'm not going to show it to you now. I'll save it for later, but it's its own little thing. Yes, it makes sense. Can we go over the last part? I understand the idea of the parentheses. Do you mean the parentheses right here? Where I've highlighted on line. Okay. So I'll just read out in plain English. That'll probably make it make more sense. Let me just do this whole thing in plain English, actually. lines 3 through 8, what I've highlighted here, are basically saying, hey, Python, can you do me a favor and create this template, right? A class called animal. And with this animal, I want the user to give us a name and then save that as an attribute. And I also want it to be the functionality where if they call this method right here, it'll print out the name. Python says, okay, I can do that. That's this. Now, when I come to lines 11 through 13, it reads like this. Python, I want you to create another template, another class called dog. But I want this dog class to inherit from this animal class. Now, what Python reads this as is, okay, I'm creating a dog class that's inheriting from this animal class. So let me take my animal class code, right, and just copy and sort of paste it into this. That's what Python is thinking as it's sort of making this code run. That's why these parentheses are saying, I'm inheriting from. And they're saying, this wolf method, right, that's not a part of this animal class, so I can add that in by myself. So I'm sort of giving this animal class as a argument, if you will. If you view it like a function, if you think about it like a function, I'm giving this animal class as an argument. So is this made to have cleaner code as well? Yeah, it is made to make your code a lot cleaner. I'll give you an example. 2 years ago, I was working on this project. It was an application, right? So you click buttons and whatnot. And what I had done was each page, right? If you click a thing, it'll open up a new page. Each page was its own class. Think about it like that. It has its own features and whatnot. And initially, the project was about 2,000 lines of code. And again, I told you guys about how I do things in iteration. That's a personal thing. And so in my final iteration, I went back and, tied them together. What is in common between this class and this class and this class and this class, right? What do they have in common? What am I adding that makes each one different? So when I added in the ability of inheritance, I cut my lines down to, I want to say 16 or 1500. I cut it down to 400 to 500 lines of code just by using inheritance. So think about that from a readability standpoint. If someone, however many years into the future, wants to read my code, they have to go through 400, 500 less lines of code to understand it. Yeah, it's pretty awesome. And again, on these smaller scales, it's hard to sort of understand why this is so useful. But I'll actually show you with our Blackjack program why inheritance can save us a lot of time and energy. So again, inheritance is one of those things that when you're creating programs, you have to keep in mind. I want to create a system where I'm reusing code, where I don't have to create new things over and over and over and over again. So yeah, are we all good with our basic inheritance introduction? And again, once we make this Blackjack game, you guys will see how awesome it is. I'm seeing a yes from Maria. Awesome. Awesome, awesome, awesome. So with inheritance, I have one more thing I want to talk about, and that's called overriding. That's how you spell it. So overriding. So again, let's look at our animal class. We have this print name method that says my name is self.name. What if with my dog class, I wanted to do the same thing? I want to have a same method called print name, makes no arguments, but instead of printing my name is self.name, right? Instead of printing just that, which we know would work, we wanted to say, and I am a dog. Now that's different. These are no longer the same thing. So again, this dog class is sort of copying and pasting the animal class code into it, right? You'll note these two methods are the same exact thing or have the same exact name. But this method is being inherited, right? This one down here is not. So let me just make that distinction. This one is inherited, and this one is not inherited. When I run this, you'll note that when I print name, it says, my name is Varun and I'm a dog. So this non-inherited method is sort of overriding overriding the one that was inherited. So again, what I mean by that is if we have a class that's inheriting from another class, that parent class, that's another term I want you guys to know, parent class, child class. Let me actually just make this distinction really clear. The child class, the parent class is whatever the child class is inheriting from. So think of the dog as the child of this animal, which it's inheriting from. It's sort of like if you get like an inheritance from an older member in your family, you're inheriting something from them. So again, this child class has overridden this method that was inherited from the parent class. So if my child class inherits a method that it needs to manipulate or change, it can do that within its own definition. So are we all good with inheritance and overriding? They're basically both part of the same little branch of OOP. Yep, awesome. And we'll see a little bit more of it with our blackjack game. I've made it so that we can get a good look with everything. So without any further ado, let me go ahead and just copy this Control X. I'll save that as a sort of, if you need to save this for later, we'll just call this inheritance.py. For reference, you can save that there. Cool. So now we can get to the fun stuff. This is the stuff I'm really excited for because I hate lecturing. It gets so boring after a while. So now we can start doing some code. We're going to get some errors. We're going to be making a game of blackjack. And I've pulled up the blackjack Wikipedia page right here in case we need to come here to check out any of the rules or whatnot. So we'll just save that there for later reference. Let me close that. So game of blackjack. We're going to be using our OOP principles. Working with something, so we're going to be working with inheritance. Inheritance. Cool. So with this project, I want to have 3 classes. We're going to be having our card class, right? Each card has its own suit, its value, and its sort of numerical points. We're also going to have a deck class. So this deck will basically manage all of our cards, allow our users to withdraw cards and whatnot. We will have a player class, and actually we'll have 4 classes. I lied. And we'll have a 4th class called our, what do I call it? I'll call it our computer class. And the reason I put it underneath this player class is this computer class is actually going to inherit from this player class. And we'll see that. So there's our little brief overview. Oh, in blackjack, it's called dealer. I apologize. We'll call it dealer then. That's a better word. Again, I honestly am not that familiar with blackjack at all, except for just coding. Cool. So let's start with what we know. This card class, we've made several different implementations of it. So let's actually just come here and let's get started. Let's start with what we know, right? We have to define this class called card. And again, we're not inheriting from anything. Our colon down there. So def init, our init dunder method. Cool. Now, what does a card need? It needs a suit, right? That's like the most important thing. It needs a face value. It needs a point value. Now, by face value, I mean like, is it a king? Is it a queen? Is it like 10? That's what I mean. Point value would be like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, so on and so forth. So when we give our card out, we need to set those as attributes, right? So self.suit is equal to suit, self dot. Our card graphic was less than 11 if you don't want to type the card art out again. Actually, that is pretty useful. I was literally about to do it all over again. So let's just go pull that. because we've explained it already. So there's no need to waste time. Thank you for that, Luke. Where is it? Probably right here. There we go. Okay. So we'll be using all of this stuff as well. Let's just copy this whole thing and we'll get rid of what we don't need. And we'll leave that tab open because we'll be using some stuff from there as well. Let me just paste everything we have. Okay. Again, this stuff is important for our deck class. I just brought it in there for now. So let's go back over what I was doing. I define them as different ways, but we have a suit, we have a rank, and we have points. So by suit, I mean something like a club, spade, ace, diamond, whatnot. And then with rank, we have queen, king, not ace, sorry. Heart. Yeah. King, queen, ace, jack. And then with points, we have our 1, 2, 3, whatever. All right. So we're all good with that. And we work with our str dunder method. So I'm actually going to go ahead and get rid of this. We know what this just prints out our card in a nice way for us to look at. So cool. That is basically our card class. And again, stop me if you need me to, go over something. But again, I'm pretty confident that, we've gone over this and used this card example a couple times. So let's just keep moving on. Now I'm going to come down here. All right, so that's our first class we've made. Now we need a way to represent our deck, right? And this is something new. The first thing we need our deck to do is make itself, if that makes sense. I need the deck to generate all of the cards. I need the deck to shuffle all the cards. And I need the deck to return a card or give a card to a player. All right. So now I'm going to come down here and say class deck. And this doesn't really need to inherit from anything. And the only thing that my deck really needs doesn't really need to take anything. All it needs to take is, we'll just say self.deck is equal to this empty list. That's where all of our card objects will get saved. Note about blackjack decks, most casinos use 6 to 8 decks to make card. Okay. I'm just doing this for the, I'll be honest, I don't really mind or care much about the whole gameplay. It's really just about the whole principle of OP that we're working with. I'm just thinking how we would implement that. Most casinos use 6 to 8 decks to make card counting harder. I'll save that for later. We'll save those additional features and implement them later on. But now you've got me thinking now. I don't want to get too distracted. But, okay. Anyway, what we need our deck to do is we need it to make itself. So we say make deck. And this is where our card generation stuff really comes in and is helpful. Again, note this ace can be an 11 or a 1, but whatever. So we can come back here to lesson 11, and we can literally just copy all of this stuff here from 46 to 49. Tab in a little bit, paste that. Oops, let's fix this. So this is going to go over all of the suits: diamond, spade, club, heart. Yeah, you get it. And we're going to pull all of our ranks and their associated points from this dictionary. We're going to create a card object, right? A card object, and we're going to add that to deck. Well, this is an attribute, so we need to say self.deck. And that is what our make deck function will do. So now let's actually go ahead and test this out. Let's just call this D. We'll make a deck. That's our deck. And again, we don't have to give it anything, right? This init dunder method doesn't take anything. And we'll call the make deck method which will generate all of our cards. And these will all get saved within our self.deck list. So what we can do is for card in d.deck, right? This d is our object, that deck is the attribute. In d.deck, we can just print card. And again, we have those str dunder methods set, so it should come out looking all nice. Make deck takes 0 positional arguments, but 1 is given. Oh, this needs to say self, because again, it's an attribute. So now if we run this, bingo, all of our cards are printed out nicely for us to view. Cool. That is our make deck. We know it's working. It's adding everything to our list. So let's get ahead and clear that out. So again, what did I say? We have to make our deck, and we need to have an ability to shuffle our deck. We'll say def shuffle deck. And this is a attribute. And we can actually use the random library for this, right? Import random. And from our random library, we can use random.shuffle self.deck. I'd be thinking, Varun, why are you making a method that just does one line of code? Wouldn't it just be better to just leave this? Again, this is a personal preference thing. You could definitely just get away with putting random.shuffle self.deck. We're going to put shuffle deck as it's just more concise. You don't have to worry about what's going on behind the scenes. And again, we can add more functionality to this. Should it clear the deck, make another one, and then shuffle it? Stuff like that. So that's why we're making a method that only has one line of code within it. The next thing I want to do is we need to have the ability to return a card, right? Pull a card from the deck. We'll say def return card, and that's a self. And we're basically just going to pull a random card from our deck. So we'll say random card is equal to random.choice self.deck. We'll return that item. And then we're removing it from our deck. So it means we also have to, delete it from our list. So we'll say self.deck.remove random card. So again, we're pulling it out, and we're also taking it away from our deck. Now what I'm going to do is we're just going to turn random card. So let's test this out so far. So again, D is equal to deck. We're going to make our deck. Let's print out the length of our deck, so D.deck. And then I'm going to just return a card. So D.return card. And if we print the length of it again, it should be 1 less than that. So it's 52. You return a card, so now it's only 51 cards big. How do we feel about this? Our deck, our deck class up till now. I wrote up something that I think created 8 decks worth of cards. Can you check? Yeah. I think I have you added in my notifications. Just give me 1 second. All right, let's take a look at what Luke wrote up. Let me publish it real quick. Okay. We'll come down here. I have Luke started following me. Okay. Lesson 13. Let's see if it's here. Show files. Actually, no, it's a separate file. Oh, I see, I see. Oh yeah, this is just the old stuff we were doing. Okay. Yeah, just let me know when you finish with that. But I'm going to assume that everyone else is okay. Fresh, is it a different thing? It's in its own REPL. Oh, okay. I see. Let's see, where is it? I'm not seeing a REPL called Blackjack. Oh, there it is. I did not notice it. I thought it was going to be all the way at the top. All right, now let's check it out. Main.py. Let's make this a little bit bigger. Okay, yep. Yeah. Oh, okay, so this is where you're doing it. Class deck, self.deck. Make deck for iron range 8. Subdeck. Subdeck. You're going to put that in the subdeck. And then are you adding... Oh, I see what you've done. You're creating 8 smaller decks, shuffling them all up, and then just putting them into the main deck. Is that what's going on? Is that valid? I don't see why not. I mean, the code looks clean. Mm-hmm. Yeah, it looks just fine. It is definitely valid. It's good code. I'm glad you're building up on what we're working with. All right, then. So let's head back to our thing. Maria, are you all good with what we've got so far? Apologies for the distraction. Oh, no worries, bro. Yes? Okay, perfect. So let's continue. So we've given ourselves the ability to create a deck, which generates all of our cards. We shuffle it. We can return cards, right? And it'll get pulled from the um, from the deck. So what I actually want to do is I'm going to come back up to this init, and I'm going to add self.makeDeck and self.shuffle. Oops, shuffle. Well, you're thinking, why am I doing that right now? Why am I putting that in my init? Basically, this is going to create my deck. It's going to be empty. It's going to assemble it with all the cards. It's going to instantly shuffle it as soon as it's created. I don't have to call these methods after I create an instance of the class. So it just saves me some time, and it just makes more sense in terms of how you visualize it. All right, so that is our deck. Now what we're going to do is we're going to create our next class. All right, so we've got our deck, we've got our card. Now we need to make our player class. So we'll say class player. Again, this is not going to pull from anything. So let's create an init self. We'll let the player make their own name, if you will. So we'll say self.name is equal to name. Now the next thing we want to do is we want to have our players deck, right? How does Python know what make deck and shuffle deck is if they aren't defined until under? Interesting question. So think about it. While this init function is the first thing that exists, Python will still check to see that these exist, if that makes sense. Think of a class as not really a top-down thing. It's more of a whole bundle, if that makes sense. With our procedural approach, right, which is functions, yeah, this would be an issue. This wouldn't work. But again, this is why classes are so nice. If you don't think about it in a top-down way, just think if this exists, then I'll be able to do it. Not necessarily where it's like, oh, it's coming after it while I'm calling it beforehand. Yeah, It's pretty awesome. So again, we have our player. Our player has a name. Our player has their own deck, right? Their own little section of cards that they have in their hand. Oops. I'll make this an empty list, actually. Our player has their score, right? Do you have, like, if I had a king and a queen, that'd be 20 or whatever. We'll have a score, so we'll just set that equal to 0. Okay. All good with that. So let's add some functionality. I'm a player, right? I have my deck in front of me. What do I need to do? I need to add cards to my deck. So we'll say def add card to deck. This method, so we'll take that self, and we'll take card. And we'll say self.deck.append card, right? Putting that card in our deck. And to our score, we also need to add the value that that card has, the card's point value. So we'll say card.point value. I think, did I put point? Yeah, just point. We'll call it points, actually. Where is it? Points. That makes more sense instead of putting just point. And actually, let me just make sure we're not worried about that later on. Okay, it's all good. We're going to add that. So, because think about it. If you get, like, again, I have nothing in my deck. If I pull a 1, I now have this 1 in my deck. But my score has also gone from 0, from nothing, to 1. If I pull a 5, that 5 is now in my deck. And my score has now gone up to 6. So that's what this is basically doing. The next thing we want to see is if we have busted. Right? Because again, in blackjack, has busted. And this is just going to return a Boolean that we can use later on in our code to check. So basically, this is going to say that if my self.score is greater than 21, because if you go over 21, then you've busted, then we're going to return true, else we'll just return false. All right? So are we all good with this so far? Because there's really only one more thing to add. Yes? Okay. Maria, are we all good? Can we explain it one more time? Yeah. Just this player class, right? Or would you like me to go a little bit higher to some elements of this? Okay, just the player class. Okay. Top down, let's take a look. What does my player have? The player has a name. We'll just use that for identification, for printing out, self.name has 1, Varun has 1, Maria has 1, Luke has 1. That's what we're using that for. Finally, we have a deck, right? So how many, the cards that'll be on our hand, we'll just call that our deck. And finally, as players, we'll have our own score. So I'm the player. I have a deck of cards in front of me. Again, I have no cards with me right now. I pull a card, right? It is a 7. That 7 is now on my hand. It's a part of my deck of cards, if you will. And that 7 has a point value of 7, right? We know that. So it's going to get added on to my total score. And in blackjack, if your score ever goes over 21, then you have busted. Then you lose. So I'm adding this here, this has busted method, to run either true or false. That if I ever call it later on in the main logic of my code, right, those while true statements where we're checking everything, when I call it there, I can use this as an easy way to just make sure if my user has busted. I don't have to go through this if logic in there. I can just abstract it into this one method that'll just tell me either yes, true, or no, false. So that's what that aims to do. Cool. Okay, so we're all good with that now. Now, there's one more thing. Let's actually go ahead and add the ability to print all of the user's cards out. Sorry, I don't know the rules. Oh, probably should have gone over that. Here, let me see if this has a good sort of history rules. I can just explain it. And Luke, correct me if I'm wrong, because I don't really know a lot about this game. But basically, you have a dealer, and then you have you. Blackjack is a betting game. We haven't really added any money aspects to it. I don't think we will. But the whole idea is you have this deck card. It's you versus the dealer, basically. So you pull a card, right? And then they pull a card, and you pull a card. And whoever goes over 21 loses. Or if, actually, let me clear that up. Let's say it's me versus you, Maria, right? I pull a card. I get 7, right? I'm nowhere close to this 21. With the rule of this game is you just want to get as close as you can to 21 without getting over. So again, I have this 7, and I'm going to either have the ability to hit or stand. Hitting means I pull another card and risk the chance of going over 21. Standing means, okay, I'll just stick with my 7. Now it's your turn. So again, I have a 7. I'm going to hit. Now I have a 10. So I have a 17. That's close to 21, so I don't want to risk going over 21. So now I'm going to stand. So again, I have 17 so far. I have a 10 and a 7. Now it's your turn. You pull an ace. We'll just say that's 11 points, right? Really close to that 21. And then you pull a 9. That ace and that 9 give you 20 points. You don't want to hit anymore because if you get anything, you'll go over 21. And so you'll say you stand. So now you have 20, I have 17. Between the two of us, you have more, and you haven't gone over 21. So you win. That's basically just how that works. Okay, cool. Yeah, and you'll see it. We'll talk about it a little bit more as we keep making the game. Can you run an instance of add card to deck? Oh, you want me to just test it out to make sure it's working? Let's try that. So in order for this to be testable, we need to have a deck to work with first. So we'll say deck is equal to deck. We'll give it a proper name this time. And again, when we call this deck class, it'll already go ahead and make it and shuffle it. So we don't have to worry about doing any of that. And we'll just say random, we'll call this a test card. Test card is equal to deck dot return card. It's just going to return this card. Return card. Okay? And then we'll have a player. And again, we'll give it a name. So we'll say Varun. A player dot add card to deck. And it'll be this test card right here. Now when I do that, I should hope to say, when I print out the player's deck, I should see one item in there. The player.deck. And I'll also print player.score. All right. And I'll actually print that test card as well out so we can see the whole layout of it. What am I doing here? I'm testing out this add card to deck method. First, I have to create a deck. I'm going to pull a random card from it. I'm going to print that card out so we can get a nice little graphic. I'm going to create a player object, and then that player object is going to add that card to its deck. And hopefully the player's deck and the player's score will change. So let's run this. Okay. So this is a 3 of, I forgot what it was, spades or something? Yeah. So that's the card we pulled, and you can see our deck is now a list with one item in it, and our score has gone up to 3. So there we go. We know that our add card to deck method is working. So are we all good with that, Luke? Or did you mean something else? No, that's what I wanted. Perfect. Perfect. Okay. So One last thing we need to do for our player class is just have them print all of their cards out. So that's easy for us to see. Thankfully, our str dunder method will make that a lot easier. So we'll say print hand. We'll just say print deck. That'll probably make more sense. Okay. Doesn't take anything, self, boom. What we'll say is for card in self.deck, right? For every card in my deck, we're just gonna go ahead and just print that card out. Straightforward, pretty simple. There we go. So that is our player class, right? Just think about it. That does basically all the functionality we needed to do. It pulls a card, adds it, checks to see if it's busted. It can print all of its card out for us to make choices and whatnot. So there we go. Now, so we've got our three classes: card, deck, and player. Now we just need to add one more. The cool thing about this one is we're going to actually inherit from our player class. So we'll say class, call it a dealer, inherit from our player class. Because again, the dealer has to do the same things. It has to add cards to their hand, the check to see if they've busted, print out what cards they've got. The only issue is that our dealer will be a robot, right? So I'm going to add one more method to it. We're going to call this one make move. What I mean by this is we have to have some way for our robot to know, oh, do I keep pulling cards? Do I not? So we'll say self. What this will do is while what's going on here? Oh, it looks like it didn't save. Doesn't really matter. Okay. We'll create a make move method. And what this will do is if, let's say that if the score, right, I can just reference this attribute because again, we're inheriting from our, sorry, I'm trying to think. Since we're inheriting from this player class, yes, it already exists with our dealer class. So if the score of our dealer is less than 18, and what we'll do is we will return true. So we'll rename this to continue pulling. Sorry, continue hitting. So what am I doing here? This is an interesting sort of take I've done. I have my player. The cool thing about my player is that I control him. I can choose to see if my player continues to stand or hit, right? The dealer has to make those decisions automatically. So we need to give it some sort of rule to say, do I hit? Do I stand? What do I do? So I'm going to say is I'm creating a method, right? Because I don't have to, you have to think, this is sort of copied and pasted already in since I'm inheriting. So I'm creating an additional method called continue hitting. And what this will do is it'll say that if the score of my dealer is less than 18, that it just hit, it'll continue hitting, continue pulling cards. And we'll use that, we'll use that in the later functionality when we use our while loop. So are we all good with this dealer class? Might be a little complicated right now because I haven't really shown you guys what it does. There's no real way to show a demo until we actually build the real thing. Not to be petty, but it's usually 17. All right. We'll just change that. Easy fix. So yeah, I think we're all good with that. So now let's go ahead and get started. Yeah, so we got all of our classes. Let's start working on our main gameplay loop, right? So what we'll say is while true, the first thing we need to do is we need to have a setup, right? We have to give our, actually, how do I want to do this? Let's have a setup thing, right? We have to give, in blackjack, you guys start with 2 cards. And correct me if I'm wrong, Luke, but the dealer um, and the player both have 2 cards to work with. So what we'll do is we'll say for I in range 2, right? It just runs twice. I will have, oh shoot, we need to create an instance of each of the classes first, actually. So we'll say deck is equal to deck, and then we'll say player is equal to player. The name, we'll say Varun, and then we'll say um, dealer is equal to dealer. Again, because it inherits from player, we do have to give it a name, so we'll just say dealer. Now what we can do is we can say for I in range 2, yeah, so the deck random card is equal to deck dot return card, and then we'll save that to our player dot add card to deck. Will be the random card. And we can just copy this, bring it down one more time. Let's call this player random card. It becomes clear who the card is going to. Then we'll call this dealer random card. Okay. So each of the players has to start off with 2. Again, if I go through and I say dealer dot print deck and player dot print deck, let me just put a little divider between the 2 of them. You see that both of them now have 2 cards. And actually, the divider is kind of hard to see, so let me make it like an asterisk or something, or just an @ sign. It'll probably be easier to divide them up. But you can see our dealer has 2 cards, and our player has 2 cards. So everyone okay with this so far? We've just gone ahead, created all the instances of the classes we're working with. And again, with blackjack, both players just start off with 2 cards. I'm seeing yes from Maria. Awesome. Awesome, awesome, awesome. And we already know from testing it out earlier that their scores have already been, have already done their adding. Because again, as soon as you call add card to deck, the score will automatically increment by the card. So we've got that done so far. So now what we need to do is we're going to come down here. I'm going to create our while loop. Say while true. First thing we're going to go ahead and do is we're going to print the hands, right? So we'll say this is the player deck. And we'll say player dot print deck. And then we'll say print f string. Oops, f string. The player has a score of player dot score. All right. So that is our thing so far. So again, let's just run this to make sure it's working. Oops, infinite loop, but yes, it is working. It says player deck, the player has a score of 16. And let's just add some \ns to make it look nicer. So yeah, it's working pretty nicely. We'll also come down here and we'll print little divider. Just make this arbitrary. Can you go back up to return card method in deck class? Yes, it's right here. Ah, dang. That was a good crack. Are you getting an error from it? No, but I just want to realize it was blank for me. Got to copy real quick. Oh, take your time then. Just let me know when you're done copying, and I'll scroll down and keep going. Okay, good. Awesome. So again, I'm just printing out the player deck. I'm printing out the score. And I'm creating a little divider. I'm just going to copy this, and I'm going to print the dealer's deck. Dealer.score. It's just so we can see that our code is working. And again, this is still an infinite loop. So just bear with me here. So our player deck is printed, score of 14. Our dealer deck is printed, score of 17. Everything looks like it's working just fine. So now what we'll do is we'll take our input, user input. What we'll say is, actually we'll call it user choice. User choice is equal to the input. Would you like to hit or stand? A little option box, H or S, right? And we'll say while the user choice is equal to H, right? Because they just want to hit over and over and over again. So while it's equal to H, so while they want to keep hitting, keep pulling cards, we're going to pull a card from our deck. Just say pulled card is equal to deck.return card, right? And then we're going to have our player add that to their deck. Add card to deck. Add that pulled card to their deck, right? And before we want to ask if they want to hit again, we have to go ahead and check to see if they busted. And again, that's why we have our has busted method up here. So we say if our player has busted, so either return true or false. So if it returns true, that means they have busted. What we will do is we'll print player has busted, dealer wins. Then we'll just break out of this whole loop. But if that's not the case, then we can ask them again. We'll say, same thing. Would you like to hit or stand now? And actually, before we do that, we need to reload this whole thing and print their new deck, right? Because they pulled the cards, we have to print out their new deck. So let's take this right here. Okay. So again, a lot of stuff has gone down. Let me just clear it up for you guys. What we've done is, as soon as our game is started, instances of the class add 2 cards to each person's deck. When we start, we need to print out both players' decks so we can see their point values and whatnot. Then I'm going to ask the user, do you want to hit or do you want to stand? If they want to hit, I pull a card from the deck. I add that to their deck. And then I check to see that if they have busted, then the dealer automatically wins. If they've gone over 21, then they automatically lose. And again, I want my user to be able to see their new deck, so we print that deck out for them. Okay? Actually, let me just, I feel like this looks really bad. So what we're going to do actually is we're going to come up down here. We're going to create a function called print hands. That'll probably make it a lot easier for us because I feel like we're going to be printing this a bunch of times. What I'll do is it'll print out both people's decks. What I'm actually going to do is I'm going to put a bunch of \n's down here. And again, I'll talk about this a little bit later on, but this is just to make it look nicer. Okay. So once we print their hands, right, we can see the player, we can see the dealer and their scores and whatnot. So once we do that, then we can ask our user again, would you like to keep hitting? Right, because that means they haven't already busted. So would you like to hit or stand? And if they say H again, then we do the same thing. But if they say anything else, like S, then it'll automatically pull us out of this, this loop. And again, this is just this while loop. So we need to come back down here, and we need to say that if our our player has busted. Again, I'm putting that not there because it'll say if our human has not busted, we'll get false, and then that not will make it a true. So if our human has not busted, that's what this is saying. Yeah. While dealer dot continue hitting. So once as this keeps returning true, right? I just put an else turn false. And I'm sorry, I'm going kind of back and forth. It's not really sounding really cohesive right now. But I'll slow down and I'll go back over everything really quickly. Basically, this is saying, okay, you want to keep hitting, keep hitting. As soon as you say stand, you now need to make sure that if my player has not busted, right, then it's time for my dealer to start hitting, start pulling cards. So while this method still returns true, while my dealer still wants to keep pulling cards, what we'll do is we'll do the same thing we did with our player. We'll have a pulled card from our deck, and then our dealer will add that pulled card to their deck. And if we can copy this as well. Say that if our dealer ends up busting, if dealer has busted, we'll say dealer has busted, player wins, and then we'll break out of this loop. And it's breaking us out of this whole if statement right here. So let's actually try this really quickly. And again, I'm sorry if this sounds a little confusing because I'm sure it does. Would you like to hit or stand? Again, it's come down here because of all the \n's I've added. We'll say, oh shit, this should be printing out the, oops, I made a mistake then. How do I want to do this? 1 second. It's just the formatting is problematic for me. We'll make this 10 then. Okay. What this is basically just doing is it's printing \n 10 times, just multiplying the string. Okay, so I have 17, my dealer has 15. It's going to ask me, do I want to hit or do I want to stand? I'm close to 17, so I'm actually going to stand. And actually, I'm actually going to put hit so I can demonstrate how we automatically will lose. If I type hit, I now have a score of 28, right? Because again, I've been printing all those \n, so that's why it looks like it's a new screen. And it should say busted. If player has busted, it should say I have because my score should be over it's 28 now. That's weird. So again, I came down here, I typed in H, while user choice is equal to H. Pulled card is equal to deck to return card. It's getting added to my player. And I'm checking to see if my player is busted. Oh, There we go. It printed right here. So the formatting is not the best thing in the world right now. We'll work on that later. But I have busted. But now it's coming back and asking me if I would like to hit or stand, which is an issue because I think what it's doing is it's just resetting this loop right here. So we know it's working so far. We still have to add the extra functionality to break out of the full loop. So if I type stand now, again, this game's not working right. So odd. Let's try this again. If I type stand, the dealer doesn't seem to be pulling cards. Oh, that's because I'm not printing the hands. That's why. Let's try this now. Let's try this one more time. If I stand, my dealer should start pulling cards. Huh. Just not doing that. Now we'll work on debugging. That is what we need to do. Our logic for this is not the best right now. Frankly, this whole section of code is kind of bleh. And again, it's probably really confusing for you guys as well. So let's actually rethink this. I don't think we've taken the right approach with this. Again, this is one of those things that you'll have when you code. You'll have an approach. It just won't seem right. It won't compute with what you're thinking. So let's think about this in a different way. Okay. I totally didn't engineer this so I can have that little spiel. Anyway, so we're gonna actually get rid of that. And again, the whole purpose of that was to show you that sometimes your approach just won't be the right way. Let's go back and think about this slower and be more methodical with how we approach this. Again, the first thing we wanted to have is the ability to print our hands. Okay. The aim of this was to give us a way to print this out and it would look nice, right? We know this works. The next thing we need to do is now we're going to work on our while true. So again, let's visualize this. I have my cards. The dealer has their cards. I have 13 points, right? I'm just using this example right here. I need to ask myself, do I want to hit or stand? So first we'll print those hands out so I know what I'm working with. We'll say user input equal to a choice is equal to user choice is equal to an input. Would you like to hit or stand, right? H or S. Okay. If I want to hit or stand. Now you got to realize with a game like Blackjack, I could be hitting multiple times. So if I'm doing something multiple times, but for an amount of time that I don't know how long I'm doing it or how often I'll doing it, a while loop is the best sort of way to approach that. Okay. What we'll say is while our user choice is equal to hit. So while they want to keep pulling cards and adding them to their list, we're going to again, pull a card from the deck. And then our player is going to add that card to their deck. Now, issue is this is I could only keep adding to my deck, right? Pulling cards, adding to my deck as long as I'm less than 21 or equal to 21. If I go over, then I instantly lose. So we'll say if our player has busted, then we have to print you have busted, the dealer wins. And this was actually the area with the last thing, because we never thought about this. When I break, right, we think, oh, that's going to exit us from the loop. but I have this while loop inside of another while loop. Okay? So what I need to do here is I now need to assess, okay, if I break out of this loop, I'm just breaking out of this chunk of while. So I'm still going to be doing this whole while loop over and over and over again. So I need to come out here. Again, I have to check if player dot has busted break. And what this will do is, again, this will break me out of this loop, and then it will come to this section. This conditional will now break me out of the full loop, which will then end the game. And that's what was the issue we were having last time. So again, if they busted, then whatever. If they haven't busted, then what we'll do is we'll give them the choice to do the same thing. Because if they say H again, we'll come back into this loop of pulling a card, adding it to the deck, checking to see if they busted, and then asking, do you want to keep going? And also what I want to do is that every time I pull a card, I want to print out the hands, print out to see everyone's decks. Okay, let's try this now. I have a score of 13. We're not worrying about the dealer right now. We're just worrying about the hitting and the standing. So we've come to our wild true. We've printed out the hands. All right. I'm now here. Do I want to hit or stand? So if I say hit, let's see what happens. I've been hit right here. I've gone ahead. I now see that a deck has been pulled and added to my deck, right? This 4 was not there, right? My score has increased by 4. I haven't busted, so we're getting this choice one more time. So if I hit one more time, you know, see, I now have 4 cards, and my score is now worth 27. So when the computer was checking to see if I've busted, right, my score is over 21, so I have busted. It prints, you have busted, the dealer wins. We now break. This break pulls us from this while loop. And when we come into this while loop, it brings us out of this as well. All right. So that's what that was doing. That was actually the issue we were having. And I wanted us to see that because sometimes when you go kind of too quick, you don't think the whole process through slowly and visualize it, you get that error or that issue rather. So we've successfully sort of dealt with our player so far. Now we need to work on our dealer. With our dealer, again, as soon as we say stand or anything else, it'll pull us out of this loop anyway. So we need to make a new loop for our dealer. What the dealer will have is, again, the way we know our dealer wants to move is if this continue hitting method returns true, right? If their score is less than 17, they'll keep pulling. So we'll say while our dealer continue hitting, again, this will either return a true or a false. So if it returns true, then what we need to do is we need to pull a card from the deck dot return card. We need to add it to our dealer's deck. Or just moving it from the main deck to the dealer's deck. Again, since we're adding that, we now want to update what the screen shows us, so we need to print the hand again. Very similar to what we did with the player. Actually, we can go ahead and copy this as well. And so if the dealer has busted, we'll say dealer has busted, the player wins, and that'll break. Again, same issue we had with the player. Once we break out of this while loop, we also have to break out of the secondary while loop. So we'll say elif the dealer has busted, break. But those will exit. And I'm not having this else to repeat the loop because it'll already happen because of this method being called and checked for if it's being true. So if we try this now, 12 and 10, I'll hit. Okay, I have a score of 19, so now I'm going to stand. Once I stand, I should hope to see that my choices, my input will no longer be there, an option. So I'll press stand. Then again, I'm still at 19, but now the dealer has pulled and they have a score of 21. And where was that? Yeah, here it was. So I stood, right? I stand. The dealer was at 10. They pulled another card. They were at 14. They were at another card. They were then at 21. So again, that 21 is greater than 17, so they're going to stop hitting. Okay? And now it's actually repeated the whole loop because I don't have something to check to see who has the greater point value now. So now I'm going to see. So if both of them haven't busted, then we have to see who has the bigger, point value. If player.score is greater than, actually we need to see if tied. If player.score is equal to dealer.score, we can say print this is a tie, and we'll break. Else if the player.score is greater than the dealer.score, then we can print the player wins and break. Else if the dealer, or we can just say, yeah, else if the dealer score is better than the player score, we can print the dealer wins or break. A lot of these break statements are chained up here. And in tomorrow's review lesson, we'll actually talk about how to make this code more efficient. So let's actually run this now. If it works. Hopefully it doesn't remove any of the progress we already had. But yeah, this is definitely confusing, so I need to go over this one more time. Oh, perfect. So all I have to put is the dealer wins. Break. Okay, so now let's run this. Let's check our while loop. We're printing all the hands. Do I want to hit or I stand? I have 15, so I'll try hitting. I now have 18. Okay, so do I want to hit or stand now? I'm going to stand. That's close to 21. I'm okay with that. So I'll stand. So where were we? We were right here. I said I wanted to stand, right? Actually, you can't even see that. I didn't even realize. I said I wanted to stand. So then the dealer started making their moves, right? You see how they have one more card, and they pulled a queen, so now their score was 22. And because of that, the dealer had busted, the player wins, game ends. So now let's try this one more time. I have 11, they have 10. So I'm going to just stand. I'm going to let them win. And as you can see, they kept pulling cards, and they ended up winning because 20 is greater than 11. They didn't bust, and they didn't keep pulling cards. So are we confused with this, actually? Let me ask that. Because I know I went back and forth. I had a little lesson about coding stuff. Are we confused? Because I know you guys are pretty good with just pulling what I'm saying really well. But I can go back and go over this with the time we have left if you guys would like me to. Because it was a lot. I didn't check in like I usually do. Probably just look over a little bit more. Let's just go over through it line by line. I have to go now. All right, you can just check the recording then. I think I'll just say this for tomorrow's review lesson then, because we're already at 1:30 anyway. So yeah, tomorrow review lesson, we will talk about this code. It's your mom's birthday. Oh, gee, oh yes, please. Yeah, wish your mother a happy birthday from me, please. So yeah, tomorrow review lesson. We'll go over this stuff again. Thank you for your patience. Take care. Be safe, everyone. And yeah, take care. And we'll see you guys tomorrow, 12 p.m. Eastern Standard Time to 12:30 p.m. Eastern Standard Time.